Let us solve this question on transformation. And the question reads, on the grid provided below, draw quadrilateral ABCD whose vertices are at A20, B13, C51, 5 negative 1, and D1 negative 2. So those are the vertices. Let's go down, see the other questions. Part B, on the same axis, draw A1, B1, C1, D1, the image of ABCD under a translation represented by the vector T, which is -1, 2. Then part C, draw the quadrilateral A2, B2, C2, D2, the image of A1, B1, D1, a C1, D1 under a reflection in the line y plus x is equals to 0. On the same axis, state the coordinates of A2, B2, C2, D2. Part D, A3, B3, C3, D3 with vertices given there. So all the vertices of A3, B3, C3 and D3 are given, and that is the image of A2, B2, C2, D2 under the transformation X. Draw A3, B3, C3, D3 and describe X fully. Then the last question, state the type of congruency between quadrilateral ABCD and A2, B2, C2 and D2. So let's go to the first question. In the first question, you're supposed to simply draw these quadrilateral. You're given the coordinates. So let me minimize this one. There's a window here. Yeah, so we can now draw these. So let me look at the vertices that I can know the scale. So we have 2, 0, 1, 0. So if I draw the x-axis here, if I draw the x-axis around the middle there, that will be the y-axis. I will have 0 there, and then this will be 1, 2, 3, 4. Or maybe I can put it to be, because I can see there are negatives. Sorry, there are negatives. So let me just draw it at the middle around here. I can see there is a -1, so I can the y-axis there. But I have 0 there. Those are the axes. So we have 1, 2, 3, 4, 5, 6, 7, 8, 10, 11. So -1, -2, -3, -4, -5. We have 1, 2, 3, 4, 5, 6, and 7. Then -1, -2, -3, -4, -5, and lastly -6. I hope these will fit. So A is 2, 0. 2, 0 will be here. That is where we shall have A. So A will be there. And then B, 1, 3. B is 1, 3. 1, 3 is here. 1, 3 is there. So that is where we have B. Then C, 5, -1, 5, 5, -1 is here. 5, -1 is there, supposed to be here. And then D, 1, -2. D is 1, -2. 1, -2 is there. So those are the points, those are the vertices of these quadrilateral. So when you're joining these, I've not named a 5, and this is C. C was here. So when you're joining, ensure that you join from A to B, A to B. You join it in that order, A to B. Then from B to C. You know why? You know whether to use a ruler for this one. So that is B to C. Then C to D. And then you join the point, the first point to the last. That is A and D. So that is how you're supposed to join it. So join A to B, then B to C, then C to D, and then join A to D. So that is the quadrilateral. Let's go to the second part of the question. So on the grid, on the same axis, draw A1, B1, C1, D1, the image of ABCD under a translation represented by the vector T, -1, 2. Translation. So how do you work questions on translation, and how does a translation work? How does it work? Simply, when you are translating a point, we're going to translate each of these points. We begin from A. So A, this is a part A. So A, which is given by, we're going to write this one in terms of the column vector, column form, in column form. So A is 2, 2, 0. A is 2, 0. We write it like that. So to get the image of A under this translation, we do add the translation vector. So I'll take the translation vector, which is -1, 2, and add it. So -1, 2. So when I do this, I'll get the image of A, which is A prime. So A prime will be given, or A1 will be given by, so simply add these, 2 plus -1, you get 1, then 0 plus 2, you get 2. So that is the point A. If you write this one in coordinate form, you write it as 1, 2. We go to B. B is given by 1, 3. 1, 3, the coordinates of B, 1, 3, write it in column form. Then translate that point under this translation represented by the matrix, not matrix, but vector. -1, 2, you will get this on this point coming 1 plus -1, this will give 0, 3 plus 2, you get 5, like that. So this one in coordinate form will be 0, 5. Then you go to C. Coordinate of C is 5, -1, 5, -1, like that. Translate that point by adding the translation vector. This will give C prime to be 5 plus -1, you get 4. Then -1 plus 2, you get 1. So this one will be translated to 4, 1. Then you go to D. Coordinates of D, 1, -2. 1, -2. 1, -2. Translate that point and you will get D prime to be given by 1 plus -1 will give 0. -2 plus 2, you get 0. So the coordinates for D, so D1 will be 0, 0. So that is how you work out that part. So you're supposed to draw it. So we can draw it now. So A, we can start with A. A is 1, 2, 1, 2. So 1, 2 is here. So this is there we have, so 1, 2 is there. So that is A1. And then B1 is 0, 5, 0, 5, 0, 5. Let me bring this one down. 0, 5, 0, 5 will be there. So that will be B1. And then C1 is 4, 1, 4, 1 will be there. That is C1. And then D1 is 0, 0. D1 is 0, 0. 0, 0 is the origin. So that is where we shall have D1. Again, we join these points. So from A1 to B1 to C1 to D1. That is how we join it. So let me join. So A1 to B1, like that. Then from B1 to C1. Then from C1 to, join this one properly. I think that one is better. So I have it. And then I have A2. You can join A prime to D1. So we have the points there. The points are now clear. So we have A1 is there. B1 is there. C1 is there. And D1 is there. We proceed to the next question. So we've answered that question. So we have drawn the quadrilateral and under that translation, and that is all. You've given the coordinates. Part C, draw the quadrilateral A2, B2, C2, the image of A1, B1, C1, D1 under a reflection in the line y plus x. Y plus x is equals to 0. Now we're supposed to take that image, whatever we have already drawn, and we reflect that under this line. Y plus x is equals to 0. So y plus x is equals to 0. This one, you can write this equation of this reflection as y is equals to -x, the same. So you need to draw this line, and this line is actually the line that passes through the middle of these axes here. The line that passes through the middle of these axes. You can use some points to plot to get that line, or you can just simply draw a line that passes through the middle of these axes from the left. That is the line y is equals to -x. So you can just pick 3 points to draw these. So x and y. So when x is, for example, 0, y will be 0. When x is -2, when x is -2, y will be 2. Okay. When x is let's say -4, y will be 4. You're just using this equation, y is equals to -x. So you can plot these points. So 0, 0 is there, the origin, then -2, 2, -2, -2, 2 is here, is a point. And then we have -4, 4, -4, 4. So those are the points. So you use these points, this one, and this one. You draw that line. So let me get the ruler and draw that line. So that is the line that we need. So this is the line, y is equals to -x. So now we're using that line as the line of reflection. And remember a very important property of reflection, that in a reflection, the object and the image points are on the opposite sides of the line of reflection, and they are equidistant from the line of reflection. So in this case, we start with the point A prime or A1. The best way to work out this, just to know one important concept, that under a reflection in the line, y is equals to the page here. So under a reflection in the line, y is equals to -x, which we are writing as y plus x is equals to 0. If you have an object point, let's say you have an object point AB, this one, under this reflection, y is equals to -x, will become -b, -a. So look at what is happening to the object points. They are reversed, and also they change the signs. So we do the same for all these points that are here. For example, A prime was 1, 2. A prime 1, 2. A prime is 1, 2. So we start with that. So A prime, which is 1, 2. Under that, this one will be A2. So this will be -2, -1, like that. So the points are reversed, and also they change their signs. So we can plot that, -2, -1, -2, -1, -2, -1 is here. So this is where it will be. A2 will be there. We get the reflection of point B1. B1 is 0.5. B1 is 0.5. So 0.5 under this reflection will be B2. The points are reversed, and also they change their sign. So we have -5, 0. So we plot that, -5, 0. So -5, 0 will be there. So that is B2, -5, 0. So this is the B2, this is B1. So you can see that under this reflection, these object point and the image point are equidistant from the mirror line. The mirror line is this line, y is equals to -x, and they are also on the opposite sides. So this distance from B1 to the mirror line is equivalent from the mirror line to B2. We go to C. C1. C1 is 4, 1. Is here we want to get the image of this. This is 4, 1. Is a 4, 1. So this one will be, you interchange these will be -1, -4, -1, -4. So -1, you plot that, -1, -4 is here. So that is C2 is there. Then the last one, D. D is 0, 0, of course. 0, 0. 0, 0 will still remain to be 0, 0. That will be 0, 0. It will still be here. So this point again will be also D2. It will be the same point for D1 and D2. So now we have the points. We have A2 here. We have B2 here. We have C2 here. We have D2 here. So we join them. So let me join them. So we start with A2 to B2. So A2 to B2 is there. Then B2 to C2, we said we should use that order that way. And then from there, we can join C2 to D2. So C2 to D2 that way. And then what is remaining? Then from D2 to A2. So we have the image of that. So here it is: A2, B2, C2, D2. So we've done that. So let's see what else is required. So you're supposed to state the coordinates of A2, B2, C2, D2. We've already done that. We've done that. The coordinates are here. So the coordinates are here. Given all the coordinates, they are all here. So we've done that. So the next question, part D, A3, B3, C3, D3 with vertices. The vertices are given. So let us first plot these vertices here. We see that particular quadrilateral, how it looks like, the diagram here. So A3 is negative 2, 5, negative 2, 5. So negative 2, 5, negative 2, 5 is here. So negative 2, 5 is there, negative 2, 5. So that is A3. And then the other one is B3 is 4, 3, 4, 3, 4, 3 is here, is 4, 3. So that is B3. And then the next one, C3 is 211, C3 is 211, 211, oh, almost out, 211, we are lucky it is not getting out, 211, 211, C3 is there. And then the next one, the last one is D3, negative 6, 3, negative 6, 3, negative 6, 3, so negative 6 you have to add here, so negative 6, 3, negative 6, 3 will be here. So negative 6, 3. So these will be D3. So now we have the quadrilateral. The only thing is remaining that just joining to get these quadrilateral. So we have A3 is there, then B3 is here, C3 is here, and D3 is here. So we join A3 to B3. We start with that. A3 to B3, A3 to B3. So A3 is there to B3, doing that using a straight line like that. Then B3 to C3, B3 to C3 is there. And then C3 to D3 like that. Okay. And then D3 to A3 like that. So there we have the quadrilateral. So it is here, A3, B3, C3, and D3. So we've done that. Let's see the question. So we're given that is the image of A2, B2, C2 under a transformation that you're not given, that is given as X. So we draw A3, we have done that. So we need to describe X fully. So we need to describe the transformation that maps this particular triangle here, A2, B2, C2, D2, to A3, B3, C3, and D3. Hope you can see the two and see the two. So from these, the transformation X maps these quadrilateral to these quadrilateral. So when we want to give that type of transformation, we need to think about all the transformation that we know. We have translation, we have rotation, we have enlargement, we have shear, we have stretch. So among all those transformations, you need to understand the properties of each transformation. That will help you identify easily which type of transformation is this. For instance, you need to look at the first thing that comes to your mind when you look at these two. You'll notice that there is change in size. The change in size. So from these quadrilateral to this one, you can see the second one is enlarged. So the first thing to think about is an enlargement because there is the change of size. For rotation, I don't see a rotation does not change the size. A reflection does not change the size. A translation cannot change the size. The other one that can change the size is a stretch. And that one, when I look at the properties of a stretch, it may not be applicable to this one. It may not be applicable to this. This one, I don't think, when I look at the two, I don't see whether the object here has been stretched. The only thing that has happened here is an enlargement. So this is an enlargement. You conclude that because you can see this change in size. Look at the points. You notice that it is actually an enlargement. Now, if it is an enlargement, how do you describe an enlargement? you describe an enlargement fully by giving the center of enlargement and the scale factor of enlargement. So let's start with the center of enlargement. How do you get the center of enlargement? This is how you get it. By joining any 2 points, let's say the object point and the image point. Let's say in this case, I will join A2 to A3, and then I can pick another one. I can join B. I can join B2 to B3. So just join those ones using a straight line. So let me start by joining A2 to A3. So A2, A3, you can see I've joined that. B2 to B3 as well. So let me join these using a straight line, B2 and B3. You can join that one as well. Now, after joining the two, you've joined A2 to A3, A2 to A3, A2 to A3, and then you've joined B2 to B3. Where are the two meeting? Where are the two lines meeting? They are meeting at this point here, the two lines, and that becomes the center of enlargement. I repeat that. After joining A2 to A3, A2 to A3 is here, then B2 to B3, the point of intersection of those lines is the center of enlargement. So this point here is -2, 1. So therefore, the center of enlargement. So you say we are describing X. So X is an enlargement center, -2, 1. That is the first thing. And then you need to give the scale factor of enlargement. So how do you give the scale factor of enlargement? By simply taking the length of the image and dividing it by the length of the object. In this case, I will pick a simple one here, like D3, B3. Okay, that one, the one that is straight. I can join these. D3, B3. Count the number of squares, the units that are there between D3, B3. So this is how we give. So let me put this one here. So scale factor of enlargement. So I join D3. I'm joining or counting. What must you join? You can just count the length and get the length. D3 to B3. B3 divided by D2, B2. So this is the image distance. That is the image distance you've picked. Over this is the object distance. So D3, B3, D3, B3, just count the number of squares between D3 and B3. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are 10. Just write 10 there. Divided by D2, B2, D2, B2, D2, B2 is here. You can see it. You can see it here. So B2, D2. So we have 1, 2, 3, 4, 5. Those are 5 squares. Those are 5 squares. See that? So once you do that, you'll get this one to be 2. To give you exactly 2. Now, another thing you need to check when you talk of enlargement, enlargement is either positive or negative. Positive or negative. We are not yet through, since when you look at the object here and the image, and you look at the center of enlargement, so look at this object and the image, and look at the center of enlargement is here. The object and the image are on the opposite sides, of the center of enlargement. In such a case, the enlargement is considered to be negative. Then another question. When is an enlargement considered to be positive? An enlargement is considered to be positive if the object and the image are on the same side with the center of enlargement. I repeat that. An enlargement is considered to be positive if the object and the image are on the same side with the center of enlargement. But if you find the object and the image are on the opposite sides from the center of enlargement, like in this case, the center of enlargement is here, the image is on upper side, then the object is on the other side. Such kind of enlargement is considered to be a negative enlargement. So this enlargement is given by -2, not +2. So therefore we have described an enlargement by giving the center of enlargement, which is -2, 1, and the scale factor of enlargement, which is -2. So that is how you're supposed to solve that question. On the last part, part E, state the type of congruency between quadrilateral ABCD and A2, B2, C2, D2. So the two triangles are the ones that I've shaded there. So these are the two, not rectangle, but the two quadrilaterals. These are the ones. So we have this one and this one. So you're supposed to state the type of congruency. Now there are two types of congruency: direct congruency and indirect congruency, or opposite congruency. So direct congruence is whereby objects can fit onto one another by just dragging or placing on top of the other object. They fit exactly on top of each other. Oppositely congruent is a situation whereby you have to turn over one object for it to fit exactly onto the other. So it doesn't just fit by just placing it and by just dragging it. And when you look at these two cannot fit unless you drag and turn over. For example, you have to turn over one of them so that it can fit onto the other. You don't just drag them to fit. So I want you to observe the two. So you have to turn it over the other side for it to fit. So these two, this type of congruency that exists between these two is what we refer to as oppositely congruent. So you can write it here. So the type of congruency is, you can say it is indirect or opposite congruency.